point 1, 2, and RP1. I'll draw here. 1, let's see, 2, so we have like this line. And R2, which is the point 1, 2, and RP1. What are some other ways to write this? Yeah, girl.
2, 4.
Yeah, this is the same point as 2, 4. And how did you get this point?
I multiplied the coordinates, or I don't know if you call them back.
Yeah. Okay, so Sophia got this by saying, well, I'm just going to I'm going to take a multiple of 2 to this point. Awesome. Okay. What else could I have used instead of 2? I could have used 3, 4, 1/2 pi e, square root of e over 2, whatever. So what might be a way that I could, well, okay, cool, great observation. So, I have a slide that says that. Yeah, right here. I could multiply by any non-zero multiple. Because what if I multiplied by 0?
0, 0.
Yeah, we no longer have a line through the origin. Okay, wonderful. So now look at part B. What were some of your thoughts for part B? So I want to express the point x, y, where y is not equal to 0. What were some of your ways of writing this point? Yeah.
X over y.
So you could just multiply by 1 over y. Is that what you did? So x over y and 1. Okay. So that is essentially, so our y coordinate is 1. So we're basically, we can represent all points like this by just collecting all points on this line. So any point that looks like this is going to be somewhere on this line, and that will give us a line through the origin in R2, which will give us a point in RP1. Is that okay? So are all of my points in RP1, do they all look like this? Do they all live? Could I kind of pick them all out by just picking a point on this line? No?
What if y is 0?
What if y is 0? Okay, so what line through the origin does that correspond to?
Like the fourth one, so like 3, 0.
Oh,
Like
okay, yeah, so
X
3,
and
0,
X.
for example. So it's this line. So this is the only point in R, or is this the only point in RP1 that I don't get? Why do we say that? Okay, and I've collected all of them here. And what?
It's never going to intersect.
Okay, it'll never intersect here. Okay. But I mean, can I, in all my points in RP1, can I write them as either like this? I guess I already multiplied by, so that's weird. Can I write them as this, or just 1, 0? Does that include everything? Yeah. Yeah. So the first definition I had of the real projective plane was like, oh, it could be any x, y for any point in R2, yada, yada. But it really just reduces down to, okay, it just looks like x with 1, and then also the point 1, 0. Not too bad. So this object, the real projective line, is pretty much just a copy of the real line. Cool, we know all about that, whatever, with a point, an extra point. And so we have a special name for this extra point. We call it the point at infinity. Okay? So we can think of RP1, the real projective line, as just a copy of the real line with an extra point. Okay? How does this feel? So I'm gonna move ahead, is that all right? That's fine, I can finish that. Okay, so now what we're gonna do is we're gonna extend this one more dimension. So now, rather than look at lines to the origin and the real plane as our points, we're gonna look at lines to the origin in 3D space, in R3, as points. So we don't really have time for this, which is fine. Okay, so the real projective plane. So the real projective plane is the set of all lines to the origin in R3, like I just said. And explicitly, it just looks like points x, y, z that live in R3 that are not all 0. Okay? So, let me just draw an example of this. Do we want RP1 still on there, or should I erase that, or should I erase, maybe I'll erase that. Is this okay? I'm gonna erase this thing. Cool. So now what I'm looking at is a copy of R3. And all of my points, here's my origin, are just lines through the origin in R3. Okay. So, let's look at number 2, and then the same notation is used. So we're going to look at question 2 on the worksheet. And actually, I have, Matt, if you could, if we could distribute the definition sheet as well.
Yes.